Okay, we're still on chapter 7, so let's finish this up. I think the last one we did was number 14, so we're going to start on number 15. So here's our triangle right here. Let's make this a little bit bigger. Let's see if I can make it a little bit bigger. There we go. There we go. And let me scoot it in place here. And then I'll use this area down here to do some writing. Maybe. Let's see if I can get this. Alright, there we go. Alright, so here's our triangle right here. This one's really, really simple. It's just made perfect for you. So look at this. These two segments are equal to each other. It says solve for x. So look, that has x in it, that has x in it. This segment is equal to this segment, so just set these equal to each other. So let's do that. When I solve for x, and I've got two x's, I'll have x's on both sides, I like to have the larger x on the left-hand side. So that's why I'm doing it like this. So I'm going to go 4x minus 35 equals 1/5 x plus 3. Alright, and now it's just basically doing some algebra. Let's scooch this down a little bit. And let's see what we can do. So subtract a 1/5 from this. Now watch what I'm going to do. Hopefully you understand what I'm going to do here. It's so much easier if you do this. If I subtract a 1/5 x from this, think of this 4 as with a common denominator of 5, with a denominator of 5. So if I put this over 5, so 1 times 5 is 5, so 4 times 5 is 20. See what I did? I took that 4x, and that 4, and made it 20 over 5. Right? So 20 over 5 is the same thing as 4. Why did I make it 20 over 5? Because I'm trying to subtract a 1/5 from it. So that just makes things a lot easier. So there we go. 20 over 5x minus 1 over 5x. 20 minus 1 is 19, so it's 19 over 5x. I hope you understand that. I just took this 4 and I changed it to 20 over 5 so I could subtract a 1/5 from it. Alright, now I'm going to add a 35 to both sides. I have to get rid of it by adding, so I add a 35, and that's going to be 38. And now we can scooch that down, or up, and we can get rid of the 19/5. Now the reason I did that, and I didn't make this into a decimal and all that kind of stuff, is because they rigged this thing real nice for you, so it comes out even. So I have to get rid of 19/5. If it's being multiplied, I multiply by the reciprocal. That's the way to get rid of it. See, the 5 cancels and the 19 cancels. Well, I do the same thing to the other side. Multiply that by 5 over 19. This is what I'm talking about when I say they rigged this so it comes out nice and even. So x equals, look at this. I don't even know if you realize this or not, but 19 does go into 38 2 times. 2 times 5 is 10, and that's what x is. That's what they ask for. They ask you to solve for x. Right there. Number 15. So that's number 15. 15 by it. That's all there is to that. Let's solve for y, and really y is the same kind of deal. Y is actually a little easier. So 16. So look, this segment and this segment both have one tick mark, so that means these two things are equal to each other, so that means this is equal to this. So let's do that. So it's 5y minus 8 equals 2y plus 1. This is even easier than what we did over here because you don't have to worry about any fractions. Well, at least in the problem itself. So watch. Minus 2y from both sides. I'm not even going to show it. You know it's going to go away. Subtract 2y from this, and I get a 3y. And then get rid of this 8. This is a minus 8, so we get rid of it by adding an 8. Again, I'm not going to show it because you should be able to do it quick. Add an 8 to this, add an 8 to this, and that's 9. Divide both sides by 3, and y is equal to 3. And that's it. So that is your answer. So x is 10, y is 3. Alright, that was easy. Okay, look at number 17. 17 and 18 are pretty much what we just did over here. If you look at this, I want to solve for x, and this is really simple. Look, this has got one tick mark, that has one tick mark. What's true about these things? Well, they're equal to each other, so let's set them equal. 3x minus 1 is equal to 2x plus 4. Subtract a 2x from both sides, and I get x. Add a 1 to both sides, I get 5. Wow, that's easier than pre-algebra. Number 18. Look, now here's the geometry. If I have 3 parallel lines and I got cut by these transversals, if these two segments are shown equal to each other, that means that these two are going to be equal to each other as well. It doesn't mean that this is equal to this necessarily, okay, but these two segments will be equal to each other. All right, that's the geometry. Once you understand the geometry, then the math is really easy. So these two are equal to each other. This segment right here and this segment right here are exactly the same. And so let's set them equal. So it's 3y equals 2y plus 2. Subtract a 2y from both sides, you get y, you get 2, and boom, there it is. So the math is really simple. Just had to understand the geometry. You had to understand that these two are exactly the same if these were the same. That's only true if all three of these lines were parallel. All right, let's do another one. All right, number 19. Now this is similar triangles and proportions and all that kind of stuff. So here's our situation. If I have two similar triangles, because I've got two arcs and one arc, I got two arcs and one arc. So that makes these two triangles similar. If I do this, if I have a bisector, see what it does? It bisected that. It's not an angle bisector, but it bisected that. It's a median actually. That opposite side right there. So if these two are equal and then these two are equal to each other, it breaks these two sides into sides that are in proportion. What in the world does that mean? It means we can compare one side to the corresponding other side. So look, if I compare them and I go 2x plus 1 to x plus 4, 2x plus 1 to x plus 4, it's a comparison. So how do you think I'm going to compare the two sides? Well, I'm going to compare the other two sides exactly the same way. So look, if I went this left side to this left side, see they're corresponding, I'm going to go 40 to 25. Put an equals in here, it's not times, it's equals. It's 40 over 25. And now we can cross multiply and we can simplify. Tell you what, I don't know if you want to do it this way or not, but when I looked at this thing right off the bat, you don't have to do this, but I looked at this and I said, oh, 5, just to make the math a little bit easier, I said 5 goes into both of those. 5 goes into this 8 times, 5 goes into this 5 times, so I could just write 8 over 5. It just makes my math a little bit easier. I don't have to work with as big a number. So I might be able to just do all this in my head without using a calculator. So now let's cross multiply. Let's multiply these together. Now notice what I did. I put parentheses around this. So this 5 is being multiplied by this entire parentheses. So I have to distribute. So let's make sure that we distribute. In fact, I'm going to write it down for you. So it's going to be 5 times 2x plus 1 equals, and then do the same thing here. Make sure you put parentheses around this. When there's a sum, you need to put parentheses around it. So it's going to be 8 times x plus 4. All right? Makes sense. And now you can see the distributing just a little bit easier this way. I mean, some of you guys might have just been able to go from here, distribute the 5, but some of you might want to see it like this. It looks a little bit better. So let's distribute the 5. So that's 10x plus 5, and then distribute the 8. That's 8x plus 32. Solve for x now. We've been doing this a bunch already just in this video. So subtract an 8x from both sides, you get 2x. Let's get rid of this 5. So we subtract a 5 from both sides, and what is that, 27? Oops. Why did I write a 5 then? I think it's 27, isn't it? And then I just divide by 2. Divide by 2 here, divide by 2 here, and you can keep it just like that. You can keep it 27 over 2 if you would like, or if you wanted to. 2 goes into 27, what, 13 times 13 and a half, or you could have written 13.5. Doesn't really make any difference. Okay, that either way. If it was me, I would keep it like that, to tell you the truth. But I know some of you guys don't like it that way, but that's fine. You can write it any of those possibilities. Alright, let's do this one right here. Yeah, let's get it just like that. Alright. Look at this. Here's another deal. Now, look, we're not comparing two triangles to each other. Well, I guess there are two triangles in here, but look, I've got one full triangle, and I've bisected this angle. So we have a thing. You don't even need to know where it is or anything, but if you want to look, it's in that chapter 7 somewhere. But we said this. If we have an angle bisector, okay, it splits this opposite side right here into two segments that are proportional to these two sides. Again, what does that mean to be proportional? It means there's ratios, there's fractions, there's comparisons. We compare one side to the other. And you're like, well, wait a minute. I can't compare 20 to this. That's what I have to do. Okay, I got to compare 20 to that because I don't know what that is. Well, look, I know that's y right there, and I know the whole thing is 28. This is what I say all the time. You might remember me saying this in class earlier. When we did this chapter, I said, well, let's just pretend that y is 10, just to make it an easy number. Okay, if y was equal to 10, then what is this segment going to be? And almost all of you could see that. If this was 10 and this was 28, you'd say, oh, that's 18. Well, it's the same thing except we don't know that's 10. So how did you get 18 out of it? You went 28 minus 10, which is 18. Now you don't know it's a 10, but you do know it's a y, so how would I find this? It's 28 minus y. So that little part that I colored in orange, that little segment right there is 28 minus y. And that's pretty important for what we're going to do now. And now we can do our comparisons. Now watch. We can compare it a couple ways, but this is probably the easiest. Let's compare it like this. Let's compare this side of the triangle to this segment, and then we're going to compare the other side of the triangle to the other segment. That's basically what this rule, theorem, I don't even know, I don't have it in front of me, I think it's a theorem, that allows you to do. So let's do that. Let's go 20 over this little segment right here, 28 minus y equals, and then this other side of the triangle and compare it to the other segment right here, and that's just plain old y. This segment from here to here is just y. So I'm going to go 30 over y. And now I have to do some math, and I got to cross multiply, so let's do that. Multiply here, that's 20y. That was pretty easy. We got to multiply across like this. Now remember, this is a sum, so we got to put it in parentheses. So make sure that you put that in parentheses and distribute. In fact, I'll do what I did the last time. I'll just put 30 times 28 minus y. Alright, and let's scooch that up a little bit, give myself some room. Alright, let's see what we can do here. We can distribute this. So this is 20y equals, distribute here. So if I multiply 30 times 28, I had to put that in my calculator, I get 840 minus 30y. Now let's get y by itself. So I add a 30y to both sides. So I add 30y, add 30y. See what I get? I get 50y equals 840, because that cancels out. Let's get y by itself. So we divide by 50. Divide by 50. Look what happens. I mean, you could put that whole thing in your calculator, I guess, but watch what I'll do. You know 10 goes into both of them because they both have zeros. Get rid of them and just put 84 over 5. I would, if it was me, again, I would just leave it like that. Some of you guys just absolutely have to put this in your calculator, and if you put it in your calculator, you get 16.8. I would accept either way, but look, why bother? I mean, because you never know. You might make a mistake and put it in your calculator incorrectly and get a wrong answer here. Just leave it like this, circle it, and I'm fine with that. I have no problem with improper fractions on there. Alright, well that's chapter 7. I hope you enjoyed that, and good luck on that part of the final exam.